Hey guys, welcome to a new video. In today's video, we're going to look at a Leetcode problem, and the problem's name is special positions in a binary matrix. So in this question, we're given a binary matrix of size m into n, where m represents the number of rows and n represents the number of columns. And a position ij inside the matrix is special if it is equal to 1 and all other elements in that row and column are equal to 0. So here in this case, you can see this element is in a special position. All the elements in this column apart from that element are zeros. This is 0 and this is 0, and all the elements apart from that element in that row are equal to zeros. So it is a special element. So the row is 1 and column is 2. So the position 1, 2 is a special position. So the count is 1. Here also there is a 1. Here all the elements in this row are zeros, but there is a 1 in that column. Here in this column there is a 1, so it is not a special position. And in this case there is a 1. Okay, in that row there are zeros, but again in that column there are not only zeros, there is a 1 here, so it is not a special position. So 0, 0 is not a special position. 2, 0 is not a special position, but 1, 2 is a special position. So the count is 1. So first I'm going to iterate through the matrix from left to right. So using nested for loops, outer loop I represents rows and inner loop j represents columns. So using the nested for loops, I'm going to iterate through the elements, and wherever there is a 1, I will access that element and check if there are zeros in that particular row and that particular column. So except that element, I'm going to check the rest of the elements in that row, and except that element, I'm going to check the rest of the elements if there are zeros. So first I'm going to check if there are zeros in that row, and next I'm going to check if there are zeros in that column. Both the conditions satisfies, I'll increment a variable count, which will be initially 0, and finally this count will represent the number of special positions, so this will be the output. Now let's implement these steps in a Java program. So first I'm finding out the number of rows in the matrix. So this is the input given to us, and this is the number of columns present inside the matrix, and this will be our output representing the count of the special positions. So using the outer loop, which is iterating through the rows, and inner loop is iterating through the columns. If we find a matrix element is equal to 0, we just continue, and I'm using a flag variable which is a boolean value which is initially false. I'll explain you what the flag will do. So now I'm using one for loop to check rows, and this for loop is used to check zeros for that column. So first I'm iterating through a for loop. We start from this element, right? It is a 1, so this will be skipped. Flag is false. I'm using a for loop which will iterate through the rows. So we start from the 0th row, r is 0, iterate through the rows if r is not equal to I. While counting the zeros, we don't have to count the current element in the rows and columns. So while counting in this row, we don't have to count this current element. So this is checking that condition. And here also, while counting the number of zeros in this column, we don't have to count the current element. So this is checking that. So C is not equal to J. So C is iterating through this column. So R is iterating through this row. So this row, if it is not equal to current element, so it will skip this. Here it will check if R is equal to, if it is a 1, we set the flag to true. It is not a 1, so it will skip. It is next element. It is not a 1, it will skip, and we reach the end of that row. Then we come out of the for loop. Flag is still false. Here it is a 0, so it will go to the next element. It is a 1. So this condition is passing, and this condition is also passing. So here we set flag to true. Now flag will become true. So we are checking if flag is false, we increment count. Count is initially 0, but flag here in our case it's true, so count will not be incremented. And in the next iteration, it will go for this element, this element, this element, this element. This condition will pass because they all are zeros. And when you reach here, again we have to check if there are rows. R is not equal to I is checking. We are ignoring this. Not count the current element. It is a 1. We set it to true. Here both are zeros, so flag will remain false. And here it will come to this for loop. We are checking for the zeros in this row. And here C is not equal to J, will ignore this current pointer element, while counting the number of zeros in that column. And if it is a 1, it will set to true, but again both are zeros, it will not go into the if statement. And finally flag is still false, so if flag is false, we increment count, so count will be updated to 1. And in the next case here also it will check it is a 1, and it will repeat the same steps. Since there is a 1 in the same column, this condition will pass and it will set the flag to true and count, and in this case count won't be incremented, and rest again it will continue with these two elements 0 and 0, and we reach the end. Finally we come out of the for loop and you return the variable count. Count is having the value 1, so for this input the output is 1. So the time complexity of this approach is O of m into n. M represents the number of rows and n represents the number of columns for these two for loops, and inside each for loop we are doing 2 more iterations for the rows and columns, so it will be into m plus n, because we are separating the rows check and columns check into 2 for loops. The overall time complexity is O of m into n into m plus n, and the space complexity is O of 1, which is constant space because we are not using any extra space to solve this question. That's it guys, thank you for watching and I'll see you in the next video.